Bismillahirrahmanirrahim. Assalamu alaikum, dear students. How are you? I hope you'd be fine. Think New Syllabus Mathematics, Book 6. And today we are going to start exercise 11b of chapter number 11, polygons and geometrical constructions. Here in this video, we are going to discuss a few properties of special quadrilaterals that includes rectangles, squares, parallelograms, rhombuses, trapezium, kites. There are a lot of quadrilaterals that we are going to deal with in this video. So watch the video till the end. Starting from question number 1, let us first talk about the properties of rectangles. So just keep in mind that a rectangle is a quadrilateral which has two pairs of parallel sides. What does it mean? It means the opposite sides are basically parallel in a rectangle. So side AB is parallel. We can say that AB is parallel to DC, and similarly AD is parallel to BC, right? And also the opposite sides are equal in length. Whatever is the length of AB, it would be equal to the length of DC. So AD is parallel to DC and also AB is equals to DC. Similarly, AD is parallel to BC and AD is also equal to BC at the same time, right? And one more thing that we have to learn, that the interior angles, all four angles of a rectangle are right angles. That is, each of the angle in a rectangle and a square are of 90 degrees each, right? So let us start with a rectangle A in question number 1, where we have a rectangle and a diagonal line AC cuts forming four angles, angle B, angle A, and 54 degrees. Even before going further, let us discuss one more property of angles, which is complementary angles. When two or more angles are formed on a right angle, they are called complementary angles. That is, the sum of complementary angles is always equals to 90 degrees. So whenever there are two or more angles that make up a right angle, their sum would always be equals to 90 degrees. It means if there is a diagonal from any of the angles of a rectangle, it would always have a sum of 180 degrees. So if we look at this side of the rectangle, that is DCB. Here we can see we have a right angle and it has been splitted by a diagonal line AC. It means the sum of the two angles, that is angle A and 54, would be 90 degrees. So we can make an equation like A plus 54 is equals to 90 degrees, because we know all four angles are of 90 degrees. So if any of the angle is splitted by any diagonal line, it means the sum of all the angles forming at that particular point would be 90 degrees. So if we just add up all the angles at any corner, at any edge, at any vertex of a rectangle, it would have a sum of 90 degrees. So we can easily find angle A by simply finding it using this equation. A plus 54 is equals to 90. Later what we'll do, we'll subtract 54 from 90, and here you go. A is equals to 36 degrees. You see, this is how we can easily find out angle A. Also, there is one more thing. If a diagonal line cuts any rectangle, that is, that the two angles on the opposite sides are cut by a diagonal, so these two angles are called alternate angles, and these are equal to each other. So we can say angle A and angle B are equal to each other. Similarly, this angle adjacent to angle A, which is 54, would be equal to the adjacent angle of B, which would also be 54 degrees. And if you find this property difficult, you can solve it another way. Like you can see that we have a triangle forming over here, ABC, right? It's a triangle. And in this triangle, we can clearly see that at point B, we have a right angle. This is 90-degree angle. At this point, we have 54 degrees. And we know a property of triangle that the sum of the three angles in a triangle equals to 180 degrees. So here we can make this equation B plus 54 plus 90 is equals to 180 degrees. Earlier, we had complementary angles. So the sum of complementary angles is 90 degrees. But when we talk about a triangle, the sum of all the angles, all the interior angles of a triangle equals to 180 degrees. There is a difference. Complementary angles have a sum of 90 degrees, whereas the sum of the angles of a triangle equals to 180 degrees. So this time the equation would be B plus 54 plus 90 is equals to 180. So we can easily find out by adding 54 with 90, we'll get 144. And in the next step, we'll simply subtract 144 from 180 and we will get the final answer, which would be again 36 degrees. So you see angle B and A both are 36 degree each. That's what we talked about earlier, that the two angles when formed in a rectangle using the diagonal line would always be equal to each other, the alternate angles, not the same side angles, but the alternate angles. It means if there is any diagonal line in a rectangle, these two angles would be alternate angles, that is, both would be equal to each other. Similarly, these two alternate angles would also be equal to each other. So what have we learned in part A? We have learned two properties, that all the angles of a rectangle are right angles. So if a diagonal line cuts rectangle at any point, the two angles or the three angles that are forming on that particular point would be complementary angles of each other. Hence, the sum of complementary angles would always be 90 degrees. And similarly, we have learned one more property, that is of triangles, that the sum of angles in a triangle would always be equal to 180 degree. Now let's talk about part B. In part B, we can see that there is no diagonal line that cuts the two vertices, but here we have two different lines from point D to E and from E to C. Now we have three different triangles in this particular rectangle. Let us start from angle C. Okay, if we talk about angle C, let us draw a triangle over here. It would become easier for you to understand that in this triangle, we have B, E, and C. If we talk about this one, we have to find out angle C. This angle is given as 39 degrees, and we already know that at point B, angle would be 90 degrees because we know all the angles at the vertices are of 90 degrees each. So each of the angle is 90 degrees. So we can say that this angle is 90 degree. Now I can easily find out angle C using the angle sum property of triangles, that is C plus 39 plus 90 is equals to 180 degrees. Again, we have used the property of triangles, which is the sum of angles in a triangle would always be equals to 180 degrees. So 39 plus 90 is equals to 129. And when we will subtract it from 180, we will get 180 minus 129, which would be 51 degrees. So it means angle C is equals to 51 degrees. Now, after finding angle C, we have to find out angle D. And if we draw this triangle outside of the rectangle, we can say that this is angle D, this is 78 degrees. And now we don't know this angle either. So how can we find this angle? We know that at point C, again, we have these two angles complementary to each other. So let's suppose this is angle DCE, right? Angle DCE is complementary to angle ECB. We can say that angle DCE plus angle ECD, these two angles are complementary, so they will have a sum of 90 degrees. You see, this angle, if we look at the angle C, it has been splitted by this diagonal line. So the sum of these two angles, this one and this one. This is angle DCE and this is angle ECB. This is angle ECB and this is angle DCE. So the angle DCE and ECD are complementary to each other. So their sum would be 90 degrees, right? And one of the angle is given out of the two, which is angle ECD. So we can say that angle DCE plus 39 is equals to 90 degrees. In the next step, we can easily find angle DCE would be 90 minus 39 and it would be 51. You see, it means this is 51 degrees. And if this angle is 51 degrees, so now we just have to find out the third angle, which is angle D, and we can easily find this angle now because angle D plus 78 plus 51 are enclosed in a triangle, so they would have a sum of 180 degrees. So first we will add these two angles. It would be 129. When we will subtract it from 180, we will find angle D. This angle would also be 51 degrees. It means angle D is also 51 degrees. And it also tells us that this triangle is an isosceles triangle. How? Because both of these angles are same. When two angles are similar in a triangle, it means it's an isosceles triangle. In question number 2, we will learn one more property that if two diagonal lines in a rectangle cut each other, they bisect each other. What does it mean? It means that we can see there are two diagonal lines, one from A to C and the other one from D to B. These are the two diagonal lines, okay? The diagonal lines cut each other, so the opposite angles that are formed are called the vertically opposite angles, because we know when two straight lines meet at a point, the two opposite angles formed are equal to each other. They are called vertically opposite angles. And vertically opposite angles are always equal to each other, right? This is one of the property that we will incorporate over here. So if this angle is 52 degrees, this would also be 52 degrees, right? And also there is one more property. Since this is a straight line, and we know that the sum of angles on a straight line would always be 180 degrees. So if one of the angle is 52, the other one would be 180 minus 52. It means this angle, that is from D to C, this angle would be 180 minus 52, which is equals to 128. It means these two angles would be 128, 128 each. It means from only one angle, we can find out the other three angles if they are forming on two straight lines meeting at a point. Okay, so what have we learned? That the two lines when meet at a point makes two opposite sets of vertically opposite angles which are equal to each other, right? Now, after this thing, we'll talk about the two diagonal lines. Look, when we have a rectangle and there are two diagonal lines, whenever we have two diagonal lines from the rectangle, these sides are equal to each other. Similarly, these two sides are equal to each other. And what happens? The four triangles that are formed would all be isosceles triangle. You see, this is triangle number 1, this is triangle number 2, this is triangle number 3, this is triangle number 4. So what do we learn? That the two diagonals bisect each other in a rectangle It means the four triangles that are formed are isosceles in nature. And what do we know about isosceles triangle? In an isosceles triangle, the two sides are equal to each other and two corresponding angles are also equal to each other. So if one angle is, let's suppose, 56 degrees, other angle would also be 56 degrees. If one of the angle is 60 degrees, other angle would be 60 degrees. If one of the angle is 70, other would be 70. This is the property of an isosceles triangle. And if we look at this particular rectangle that has been given to us, we can see that there are four isosceles triangles forming, and we know one of the angles. So if we are provided with any one angle in an isosceles triangle, we can easily find out the other remaining angles. How? Let us talk about it. Look, if we have an isosceles triangle, and we have to find out the two angles that are equal to each other, and the angle which is not equal to any of the angle is given. For example, let us take this triangle AEB. Okay, it's an isosceles triangle. These two sides are equal to each other, so these two angles would also be equal to each other. Okay, this is angle E, and we have already found that angle E is equal to 128 degrees, right? So we can easily find out each of the angles EAB and angle ABE. We can find these two angles. This is angle EAB, center is A from E to B, and this is angle ABE, center is B. So this is ABE, right? Since these two angles are equal to each other, how can we find out this angle? We will say that first we will subtract the given angle from 180 degrees. We will get 52. And now in the next step, we will simply divide 52 by 2. We will get 26 each. It means each of the angle is 26 degrees. You see, it means both of the angles are 26. And now if you add the three angles, 128, 26 and 26, you will get 180 degrees, which is the sum of the three angles in our triangle. You see, this is how we can easily figure out that what would be the sum of the three angles in a triangle. In the same way, we can find all of the remaining angles. So if these two angles are 26, it means these two angles would also be 26. And now we just have to find out the remaining angles. So we can find it out by using any properties. That is, the property of complementary angles would also be applied over here. And same, we can do the same with this one, since these two are also the isosceles triangle. So we can say that if we subtract 52 from 180, we will get 128. In the next step, what we will do, we will divide 128 by 2 and we will get 64. It means the two angles would be 64. And now we can check using the properties that have we found the angles correctly or not. We will start the working slide. Given that two diagonals AC and BD intersect at point E, as you can see in the given picture. So angle AED and angle BEC would be vertically opposite. These two angles we are talking about, and hence both would be 52 each. And then angle DEC and AEB would also be vertically opposite. That is, these two angles would also be equal to each other, and they would also be supplementary to angle BEC. So it would be 180 minus 52, which is equals to 128. So this is how we can easily find out all four angles on two lines that are intersecting at a point. Then we have to talk about the four angles that are at the ends. So if we look at the two diagonals, they bisect each other. Bisect means they cut the two lines into two equal parts. So these two parts would be equal to each other. That is, AE would be equal to EC. We can say that the length of AE would equal to EC Similarly, the length of DE equals to EB. And in this way, what will happen? All of these lines would be equal to each other. AE, EC, DE, EB would all be equal to each other. Their lengths would all be equal to each other. And what would happen? This would have an impact on the triangles, that all four triangles would be isosceles in nature. And the property of isosceles is that two of the angles in an isosceles triangle are equal to each other. So all the angles that we have to find are equal in their triangles. So we can easily find the triangles now. How? We will write this property that since the two diagonals bisect each other, hence all four triangles formed are isosceles in nature. So to find angle ADB, what we will do, we will write it as ADB is equals to DAC. These two angles are equal to each other. ADB and DAC. These are two equal to each other angles. So first what we are going to do, we will subtract 52 degrees from 180, we will get 128, and then we will divide it by 2. So we will find the two angles that are equal to each other. In this way, we can find angle ADB, and same finding ACD, we can easily find angle ACD and angle BDC. These two angles are also equal in nature. So what we will do, first we will subtract 128 from 180. We will get 52. Then we will divide 52 by 2 to find out the two unknown angles that are equal to each other, and we will get 26, 26. You see? These two angles are 26, 26, and these two angles are 64, 64. And if we add 64, 64, and 52, we will get a total of 180. It means we have found the correct answer. Similarly, 26, 26, and 128 also gives us the total of 180 degrees. It means it is also correct. Okay, so we have done question number 1 and 2. Inshallah, in the next video, we'll try to solve the next questions. Until then, take care. And if you are new to the channel, do subscribe to my channel and share it with your friends as much as you can. Take care. Allah Hafiz.